Imagine stepping outside tonight, looking up at a bright full moon, and watching it simply blink out of existence. What actually happens to our planet the exact second our closest celestial neighbor vanishes? The most immediate change isn't the loss of light. The real crisis begins with a sudden, drastic drop in the physical power of our oceans. This diagram illustrates the tide-generating potential of the Earth-Moon system. Because of its proximity, the Moon's gravity accounts for nearly 67% of Earth's total tidal force, physically pulling the oceans into these two massive bulges. Without the Moon, these tides immediately shrink to 1/3 their normal size. The water levels flatten out, leaving only a much smaller, uniform bulge driven by the Sun's weaker, static gravitational rhythm. This breaks the ocean's primary mixing engine. Without the constant churn of lunar tides, the distribution of nutrients and oxygen throughout the water column begins to fail. Over the following months, the stagnation reaches the coastlines. In estuaries where freshwater and seawater once mixed vigorously, the water goes still. Salt marshes, which rely on the daily influx of the tide, begin to dry out. As the vegetation dies off, the entire ecosystem starts to decompose. This rotting vegetation creates a chemical chain reaction. These marshes were once massive carbon sinks, but as they decay, they release their sequestered carbon and methane directly into the atmosphere. The death of the tides removes a primary driver of coastal health, creating a global warming feedback loop that begins to shift the temperature of the entire planet. Gravity isn't the only way the Moon regulates the biosphere. Consider the Great Barrier Reef, shown here. Marine life in these ecosystems is as dependent on the Moon's light as it is on its pull. More than 130 species of coral possess light-sensitive neurons. They wait for the dim blue light of the full moon to trigger and synchronize their mass spawning events. Permanent nocturnal darkness desynchronizes this process. When corals release their gametes at different times, they fail to reproduce, threatening the survival of reef systems that support a quarter of all marine biodiversity. Human biology is similarly hardwired to these cycles. Studies show our deepest sleep stages and melatonin production levels are still synchronized with the phases of the lunar month. Earth's biosphere operates on a schedule set by the Moon. Without that celestial cue, these ancient reproductive and biological rhythms fall out of sync with the environment they were built for. Fast forward millions of years, and the most hidden consequence of a moonless Earth finally reveals itself: the total destabilization of our planetary axis. Earth currently rotates at a stable 23.5-degree tilt. This specific angle ensures that sunlight is distributed evenly enough to maintain predictable seasons and a temperate climate. In 1993, astronomer Jacques Lescar published these calculations. He demonstrated that without the Moon's presence, this stable 23.5-degree tilt would become impossible to maintain. These graphs illustrate the chaotic zone. Without the Moon acting as a heavy anchor, the gravitational pull from planets like Jupiter would cause Earth to wobble erratically on its axis. The tilt would swing anywhere from 0 to 85 degrees. Temperate regions would suddenly face Arctic freezes as glaciers violently advance across the landscape, shattering the climate stability required for complex life. The Moon serves as a geophysical shield, actively protecting our climate from the chaotic gravitational influences of the rest of the solar system. In reality, the Moon won't vanish tonight, but it is slowly drifting away at 3.8 centimeters per year as tidal friction gradually saps Earth's rotational energy. The Moon is the invisible anchor that maintains Earth's biological and geophysical predictability. Its presence is a prerequisite for the world as we know it.